Hello, explorers. Welcome back to Stardust Discovery. On today's episode, we'll be looking at a continuation of wave particle duality. And just a reminder that this question is taken from the Physics WASSCE question from June 2021. So we have this question: state 3 observable phenomena where a particle behaves like waves. Remember when we talked about wave particle duality, it is a concept where we see that light can behave like a wave and sometimes like a particle, depending on the experimental conditions. So this question is asking about some of those observable phenomena that makes a particle to behave like waves. So in order to answer this question, I would suggest that you go read up on wave particle duality and the different phenomena that makes a particle look like it's behaving like a wave, and also the phenomenon that makes it behave like that shows that it behaves like a particle. There are, two distinct phenomena that tries to show these two different behaviors. And I have some links on the description box that will be useful, and also a link to my previous video on this topic. And about this question, getting back to it, there are different phenomena that have been observed. Some of them I've highlighted. Electron diffraction as they pass through a crystal. There are different ways diffraction can occur. This is just one of the examples. And if you remember the different properties of waves, diffraction is one of them. There is refraction, there is reflection. I will also encourage you to read up on properties of waves. Those are also very important. Interference, polarization. So all of those things should be exhibited, or one of them or two of them, should be exhibited by by light or by an object, for that light or that object to have a wave-like behavior, right? So I mentioned electron diffraction. There is a double slit experiment as well. Some of these things you'll find from your textbook. I'm also including links that will explain them further in the description box. Quantum tunneling of particles. Quantum tunneling of particles is a phenomenon where particles penetrate through a potential energy barrier. It is more like a particle passing through a wall where there is clearly no way of escape, but then it did pass through and come out on the other side. That should be funny. But yeah, we've seen such behaviors, and this is not able to be explained by classical physics. So classical physics is a normal physics where you can add up equations and they give you something like it's very simple to explain. It's more trivial, but it turns out that life is beyond classical physics. So there is a lot of behavior and phenomenon that classical physics cannot explain. You need to get to the very microscopic level, which we call the quantum physics, to able properly explain those behaviors. And quantum tunneling is one of them. In fact, the wave particle duality is one of those phenomena that classical physics defies, or that defies classical physics, right? There is absorption and emission by atoms. Absorption and emission. If you remember your chemistry days, you did a lot of energy levels. When you absorb an atom, an electron, you go to higher energy levels. When you lose an electron, you go down to a lower energy level. That explains absorption and emission. That behavior as well, we attribute those to wave-like behavior. There is also what is called photoelectric effect. This is the behavior of light in the presence of an electric field. So I would encourage you to go read up on these things. Yeah, this question expects that you already know these things, such that when you are asked, you can quickly highlight these points. There are other points that I have not mentioned. Feel free to add them. And then I hope this was helpful. Thank you so much for watching, and do not forget to subscribe, comment, like, and share this video. And I will leave you with the word of Dave Willis. Your life has purpose and your dreams have meaning. Hold on to hope for brighter days ahead. And I will see you in our next video. Bye.